So in this class we will see the development of the oral cavity. So we are now doing the head and neck embryology. We have covered the pharyngeal arches, development of the face, palate, tongue, thyroid, nasal cavity. In continuation of this, we will now see the development of the oral cavity and also the associated glands of the oral cavity also we will see in this class. The mouth cavity consists of two parts, primitive and definitive. Primitive and definitive. The primitive mouth or primitive oral cavity is derived from the ectodermal stomodium. And the definitive mouth is derived from the cephalic part of the foregut and it is endodermal. Both are separated by the buccopharyngeal membrane in the beginning. After its rupture, both communicate. So communicate with each other after the buccopharyngeal membrane ruptures. What are the derivatives of this? Primitive stomodium, ectodermal stomodium, and the definitive endodermal part of the foregut. So first, the stomodium is divided by the development of the primitive and permanent palates into nasal and oral cavities. The oral part of the stomodium forms the mucous lining of the cheek, lips, gums, and enamels of the teeth. The nasal component of the stomodium forms the mucous membrane of the nasal cavity, nasal septum, and the palate. So the oral component of the stomodium now we are seeing gives rise to the mucous linings of the cheek, lips, gums, and enamels. The floor of the definitive mouth is derived from the cephalic part of the foregut. And in the floor of the mouth also we have seen already the development of the tongue rudiments. So in the region of the floor of the mouth, mandibular process give rise to the tongue rudiments. Roof of the oral cavity has been already formed by the palate. Subsequently, the epithelial linings of the epithelial cells lining the margins of the primitive oral fissure proliferate outwards into the surrounding mesenchyme. Eventually, the epithelial cells break down and the ectodermal alveolo-labial sulcus separates the lips and cheek from the gums and teeth of both jaws. So, cheek, lips, gums, everything is derived from oral stomodium, now only we told. It should be separated. That is by the ectodermal alveolo-labial sulcus. Ectodermal alveolo-labial sulcus. The same period, the oral part of the tongue separated from the floor of the definitive mouth by the endodermal alveolo-lingual sulcus. So these are the two sulcus which are separating this mouth components. Development of the salivary glands develop as solid outgrowths of the epithelial lining of the oral cavity. So from the epithelium of the oral cavity, they develop as solid outgrowths. So you are seeing in this picture oral epithelium, they outgrow into the surrounding mesenchyme, forming in the beginning rudimentary bud-like structure, and simultaneous branching gives rise to the branching of the ducts, and lastly alveolar cells will be formed. First we will see the development of the parotid gland. Develops during the 5th week from the angle of the primitive mouth or primitive oral fissure as an ectodermal furrow which grows outwards between the mandibular arch and the maxillary process. Later, the groove is converted into a tube that will form the parotid duct. So, the parotid duct opens medially into the angle of the primitive mouth. From the lateral end of the duct, cords of ectodermal cells project into the surrounding mesenchyme, and subsequently they will be canalized to form the acini and ductules of the parotid gland. Thereafter, the angle of the mouth is shifted more medially by the fusion of maxillary process and the mandibular arch. Parotid duct in adult opens into the vestibule of the mouth, which indicates the position of the angle of the primitive oral fissure. The ectodermal origin of the parotid gland is proved by the presence of the myoepithelial cells in the acinar walls. The submandibular glands and sublingual glands we will not see in the histology myoepithelial cells. Only which glands develop from the ectoderm will have the myoepithelial cells. So this is how between the two process, maxillary and mandibular process, this parotid duct develops as an ectodermal furrow. Later the groove is converted into a tube which forms the parotid duct. Submandibular glands, each gland is developed from the 6th week as the solid endodermal outgrowth from the floor of the stomodium during the 6th week. Otherwise from the floor of the alveolo-lingual groove. The outgrowths are subsequently same like parotid gland, canalized to form acini and ductules of the gland. The edges of the floor of the groove into which ductules open gradually fuse from behind forwards and form the submandibular duct, so that the duct opens on the sublingual papilla on each side of the frenulum linguae. Sublingual glands as multiple endodermal outgrowths from the linguogingival sulcus or alveolo-lingual sulcus, and also from the submandibular duct, but they develop somewhat later in the 8th week. Each outgrowth canalizes separately and opens independently on the summit of the sublingual fold. So it is somewhat different, multiple endodermal outgrowths. So we have completed the development of the submandibular and the sublingual glands. Both are endodermal derivatives. Parotid gland is an ectodermal derivative. So these are the salivary glands associated with the oral cavity. We will see in this class also the development of the pituitary gland. Pituitary gland is partly related to the oral cavity and partly related to the nervous system. So we will cover this also in this class, development of the pituitary gland. Pituitary gland develops from two different sources, ectoderm lining the roof of stomodium and neuroectoderm of the hypothalamus or the floor of the third ventricle. or the new rectoderm of the diencephalon. The third week of intrauterine life, ectodermal diverticulum called RATHKE's pouch vaginates headwards from the roof of the stomodium in front of the buccopharyngeal membrane, and the cranial end of the notochord extends up to the floor of the forebrain vesicle. The growth of the surrounding mesenchyme gradually constricts the stalk of the pouch so that finally the stomodium and the RATHKE's pouch will be completely separated by the second month. The cephalic part of the RATHKE's pouch forms the anterior lobe of the pituitary gland. The cells covering the anterior wall of the pouch proliferate to form pars anterior. This part extends headwards towards the floor of the diencephalon along the infundibulum and persists as the pars tuberalis. The posterior wall of the pouch forms the pars intermedia. So these are the three parts of the anterior lobe: pars anterior, pars tuberalis, and pars intermedia. The cavity of the pouch usually persists after birth as an intraglandular cleft. You should have learnt in the histology of the pituitary. There will be a cavity in the anterior lobe. The position of the commencement of the pouch corresponds with the junction of the nasal septum and the palate. Then the posterior lobe development. So this is the diagrammatic representation of the development of the pituitary gland. Roof of the stomodium gives rise to the RATHKE's pouch, which grows towards the floor of the forebrain. Now, during the 6th week, a funnel-shaped diverticulum grows caudally from the floor of the diencephalon and lies close to the dorsal surface of the cephalic part of the RATHKE's pouch. The lower end of the diverticulum differentiates to form a solid mass which is converted into the posterior lobe. The commencement of the diverticulum forms the infundibulum and its cavity persists as the infundibular recess of the third ventricle. Although the posterior lobe is neuroectodermal in origin, it contains no nerve cell in the human embryos. Most of the cells are neuroglial, and the posterior lobe is invaded by the nerve fibers of the hypothalamus. So from the floor of the third ventricle, that is the neurohypophysis development as from the vagination of the new rectoderm. Applied anatomy of the development of pituitary gland. Pituitary adenomas may be present or the craniopharyngiomas. So this we have completed the development of the oral cavity, salivary glands, and also the pituitary gland. Pituitary gland is partly related to the oral cavity. This pineal gland is not related to the oral cavity, but same like from the floor of the third ventricle, this pineal gland develops as a small diverticulum from the roof of the third ventricle. So to complete this, we have added the development of the pineal gland in this class. I think you should have all understood this. All these salivary glands, development of pituitary gland may be asked as short notes for you. We have covered the development till now. Development of in the head and neck region, we have covered the development of palate, nasal cavity, oral cavity, tongue, thyroid gland. The remaining we will see in the next class.